Civil 3D makes extensive use of dynamic objects. That means that you do not draft your designs with simple lines, arcs, circles, and polylines. Instead, you create objects like points, surfaces, alignments, profiles, cross-sections, corridors, pipe networks, and parcels. This object-oriented approach allows you to create a dynamic design where the objects interact with each other. For example, a point is used to build a surface, and then that surface may be used to create a profile or section, or it can then be the daylighting target for a grading object or corridor. If that original point is edited, then the surface updates, and those changes translate to the profiles, sections, gradings, and corridors that are all interacting with that one point. In this exercise, there is a surface, an alignment, a profile, and a small corridor. To understand these objects more, look at the surface in greater detail. Click any contour line on the surface. See how it lights up like a block? This is a surface object. Now open the Properties palette, and then click the surface again. Notice that this surface is on the layer C-Topo-EG. This is the main layer the surface object was placed on. Freeze the layer C-Topo-EG, and the surface disappears. Now go over to the Toolspace, Prospector tab, and expand the Surfaces collection. The EG surface appears here and has not gone away, so the data is still in the drawing, and it is still accessible. Pan over to the right and you can see the profile and profile view that were made from the surface. The existing ground line, which is red and hidden, is still visible. So even though you froze the surface, the data is still accessible for creating profiles and corridors. An object can be frozen or turned off and not seen in the drawing window, but the data is still accessible to any other object within the drawing as long as it is in the Prospector. Thaw the C-Topo-EG layer to bring back the surface to your screen. Civil 3D objects all have properties associated to them that can be manipulated to reflect what you may want their data to represent. Select the surface. Right-click and choose Surface Properties. You can also access the same Properties dialog box by going to your Toolspace, Prospector, expand the Surfaces collection. Find the surface name, right-click and choose Surface Properties. Those are the two fastest ways to access a Properties dialog box for any object. Either method opens the Object Properties dialog box. In this case, you're accessing a surface, so the dialog box title bar will be Surface Properties, name of your surface. In this box, there are 4 tabs: Information, Definition, Analysis, and Statistics. The Information tab is where you name the object, set a style or look for the object, set the render material for the object so that when you rotate or twist your model in 3D, it looks like something other than wireframe linework. And you can lock your object in some cases. Every object has an Information tab by default. The remainder of the tabs depends on the type of object. The next tab, Definition, is specific to surfaces. Here you can define how your data is used for the building of the surface. Under the Definition options, expand the Build collection. Here you can tell the surface to ignore elevations above or below a set elevation. You can set a maximum angle for the tin network. If a tin line goes over this angle that you set, it will not be made. The same is true for maximum triangle length. No tin line will be made over this length if you set this option. You can allow any breaklines that cross to be ignored or used. Expand the Data Operations collection. Here's where you can tell the surface whether or not to use all the boundaries, breaklines, and contour data for your surface by designating yes or no. Lastly is the Edit Operations collection. Here you can allow your surface to be edited by adding a point or adding a line or tin line to the surface, again by designating yes or no. In the operation type box below, you can see how this surface is built. You can switch up the order in which the surface is created by selecting what you would like to move, such as this boundary. Select the boundary, and then use the move arrows to send the boundary all the way to the bottom of the stack so it is the last item. Also, these breaklines are in the wrong place in the operation. They should be after the surfaces. Select the breaklines, and again use the move arrows to move the breaklines to just after the surface. Click Apply to accept the changes. A warning appears asking if you want to rebuild now or just leave it as it is so you can rebuild it later. Select Rebuild the Surface and your surface is now rebuilt with these new settings. On the next tab is the Analysis tab. Expand the Analysis Type dropdown to see what options can be set in the properties. Select Slope Arrows. Leave the legend area alone, but be aware that if you decide to use your own legend, you can set that here. Under Ranges, change the number to 3 and then click the down arrow to the left. This populates the range details box where you can actually change the ranges for slope arrows that you want to display based on what this surface really is. Set the ranges starting on the red range to 0 to 5, then 5 to 10, and 10 to 100. Then click Apply. When you try to go in order to change these, a warning appears stating that the slopes are out of range. In this box, you must work backwards so that your minimum slope is never greater than your maximum slope. One thing to note, this box is for setting up how you want your analysis options to be calculated. You will use the styles for the object to turn these analysis options on or off for display. Lastly, in the Surface Properties dialog box is the Statistics tab. This tab shows you a summary of the object you are dealing with. In this case, you see a summary of the mean elevations, areas, and triangles or tin information. Learning to understand and work with these objects is a key component to Civil 3D.